So welcome everyone to Closed Licenses, Closed Doors. I'm Summer Rosonovski and I'm the Senior Community Outreach Officer, and today I'll be going over what Europe PMC is and a brief introduction of the licenses. So Europe PMC is an open database of global life science literature. It provides a stable and permanent digital repository of global life science content, and it's freely accessible for anyone, anywhere in the world. Europe PMC is developed by EMBL EBI. It's a partner of PubMed Central and endorsed and supported by a group of 35 international science funders, and it's their repository of choice. And this means that their researchers can index their work into Europe PMC to ensure that they meet their funders' open access policies. Europe PMC contains over 47 million publications, and that includes abstracts from PubMed, full text from PMC, and preprints from 34 life science preprint servers, and that includes bioRxiv, Research Square, and preprints.org, to name a few. Europe PMC also includes other documents, and this includes books and theses, and it's enriched with links to supporting data, reviews, and other relevant resources, helping you see that bigger picture of the research. So you can access content in Europe PMC using the main search bar on the website, and this allows you to use keywords and phrases. You can also go into our advanced search, and this allows you to build more complex queries to run more specific searches, find those key bits of information that you're looking for potentially in the methods and in the results. And you can also programmatically access this content using Europe PMC developer resources, and this allows you to do bulk downloads and also utilize our APIs. So what are Creative Commons licenses? So Creative Commons is the nonprofit, and they are behind the open licenses that are known as CC. So these were established in 2002, and they make it possible for everyone around the world to share knowledge creatively, legally and freely. And the CC licenses offer different license types and allow the author to decide how to grant others which way that they can use their work. So it lets you set the defined terms for how your work can be used. So when we look at CC BY, this enables the reusers to distribute, remix, adapt, and build on the material in any medium or format. Attribution must be given to the creator. This license also allows for commercial use, meaning that someone can reuse your work as long as they attribute you. For example, this slide here was created by Taylor Campbell from Creative Commons, who made the slide for the Europe PMC and Creative Commons webinar, What Happens When You Choose Closed, and what creative licenses mean for research and AI. So this is the way that I have attributed that work here. And I should add here that many funders recommend or require a CC BY license for open access publications, and it is the least restrictive license of those shown here. We also have a share alike, abbreviated to SA, which enables reusers everything the same for a CC BY, with the addition that if you remix, adapt, or build upon the material, you must license the modified material under the same or compatible license. So this adds a restriction on what licenses those reusing your work can give to that reused work. There is also non-commercial license, which is abbreviated to NC. And this enables reusers to distribute, remix, adapt, build on the material in any format, but it must be non-commercial. So as long as that attribution is given to the creator and it's non-commercial, that can be used. So this license is adding a restriction that reuse is only for a non-commercial purpose. There is also no derivatives, which is abbreviated to ND. And it enables reusers to copy and distribute the material in any media or format in an unadapted form only. And again, you have to attribute the creator. This license does allow for commercial use, and it restricts derivatives that change the material in any way. This is your most restrictive license shown here. So what's important to note here is all of these licenses require attribution, and you can combine the licenses to the terms that you want. For example, you could use a CC BY NC SA, which would mean reusers can distribute, remix, adapt, and build on any of the material, but it must be for non-commercial purposes only. And attribution, of course, has to be given to the creator, and anyone building on your content and reusing it must use the same license you gave it. So that's the brief introduction to Europe PMC and the different types of licenses. So now I would like to hand over to Dr. David Hulcoop, the Director of Open Targets, and he will be sharing with you today how licenses choices affect the pioneering drug target identification that Open Targets does. Thank you very much. Over to you, David.
Thanks, Summer. Hi, everyone. I'm just going to share my screen. Okay, does that look like it's coming through okay?
Yep.
Okay, and can you see the slides now?
Lovely. We can see that, David.
Okay, I'm just going to minimize that. Okay, so thank you for the invitation to come and talk today. What I'd like to tell you about is a way in which we've built something to address a big research question, which is enabled by the licenses that the people who look after the fundamental foundational data have provided and enabled for the community. So I'm the executive director of Open Targets. And what Open Targets tries to address is a big problem in drug discovery, in that 9 out of 10 times when we try and bring a new medicine to life, to bring it to the market, to bring it to patients, we fail. And we often fail because the drug is not safe enough or the drug is not efficacious enough. It doesn't work as well as we thought it would at the beginning. And Open Targets is a consortium that brings together academic institutes that are based at the Wellcome Genome Campus.
The last yellow stuff? We've been watching. No.
Okay, I'll carry on. Sorry. Open Targets is a consortium that brings together the academic institutes at the Wellcome Genome Campus, that's EMBL EBI, and the Wellcome Sanger Institute, and the pharmaceutical industry represented at the moment by 5 partners: GSK, Sanofi, Pfizer, Genentech, and MSD. Now, the reason we're bringing these partners together is to build a program of research that tries to improve the success rates of drug discovery by being more systematic about how we identify and prioritize drug targets. And these are the foundations of all drug discovery programs. And if we make that first decision incorrectly or in an uninformed way, we're likely to run into trouble later on in the process. So as I said, targets are the foundation of drug discovery programs. And what we're trying to do with Open Targets is develop therapeutic hypotheses, which are simple in concept. Essentially, if we modulate some part of our biology, can we bring benefit to disease? So a therapeutic hypothesis is a kind of simple concept. But to develop it fully, you have to answer a lot of questions to do with the association of the target to the disease, to do with whether or not you can do anything about that, to do with whether or not the intervention you want to make is safe, and to do with how you're going to position your intervention versus the other things which are already being developed by others or already on the market. We put together some of the questions around therapeutic hypotheses into this article that you'll see linked here. But fundamentally, what we try and do to address those questions is find evidence that can help us answer those questions. So we use evidence from lots of different sources to build therapeutic hypotheses between targets and disease. We do that by generating our own evidence within the consortium, which I won't talk about in detail today. And a large part of our efforts are devoting to trying to understand what's available in the public domain that associates targets and diseases and bringing it together into a unified framework. So Open Targets, the consortium, makes the Open Targets platform. This is available at platform.opentargets.org. It's a freely available open source resource for the community. It's accessible via a web interface and also via things like APIs and MCPs, which I'll talk about a bit more later on. The goal of the website is to help people who are interested in targets find the diseases that they are associated with, and for people who are interested in curing diseases, find the targets that can address and bring benefits to patients. So we try and build target disease associations and aid therapeutic hypothesis building so that you can make the best decisions when you're doing drug discovery. And we need to bring together lots of different data sources to enable us to do that. So on this slide, it represents all the different data sources that Open Targets work with that have licenses that enable us to bring their data together and integrate it to understand the evidence between targets and diseases. Just to sort of clarify how Open Targets works, we are not a sort of database of databases where we download all the data and put it all in one place. We leave the data with the expert repository, and then we extract the evidence that associates targets and diseases and bring the evidence together so that you can see how it all stacks up. When you use the Open Targets platform, it looks a bit like this. If you search for something like Alzheimer's disease, what you see in the screenshot here is a list of the targets that could be potential beginnings of therapies if you were to pursue drug discovery against them on the left-hand side. Things like APP, PSEN1, PSEN2, ApoE, etc. Then in the little blue circles, that shows you that there is evidence that associates these targets to that disease from the repositories that we talked about on the previous slide. In the user interface, you can click and explore this evidence, and it comes from lots of different sources, such as common and rare genetics, known drugs and clinical trials, somatic mutations, perturbations and pathway analysis, literature sources, and here's where Europe PMC comes into the fore for us, expression studies and animal models. And we build an overall integrated association score that summarizes the strength of the evidence that associates any target to any disease based on the different data sources that we work with. So the website is great, and I encourage anyone interested in drug discovery to go take a look and explore what we've done there. But we also know that there's many different new paradigms emerging in the way in which people tackle and address big questions, enabled by AI and new interfaces that are coming to the fore. We've done some benchmarking to understand what happens when people make the types of inquiries that they make within the Open Targets platform in general purpose large language models. And what we can see is where something is fairly well precedented, you can often get relatively high accuracy. But where you're at the edges of knowledge or things are less well precedented, you're at higher risk of things like hallucinations happening. You will always get an answer, and that's important. I'll come back to that in a minute, but the answer is not always correct. What we think can help here, and there'll be many solutions to this as we move through time and the technology addresses, is the use of things like tools to connect the kind of large language model interfaces with these structured databases so that you can retrieve the correct data for any given question. At Open Targets, we built such a solution using current technology, and that's an MCP, so that for any large language model, you can interface with Open Targets MCP. And for the different questions that you're interested in answering through this kind of more open interface, and here you can see some of them arrayed on the slide in front of you, you can connect them to the source of evidence that enable you to answer them to the best degree and to the highest quality with the most accuracy. Those little logos shown on the right-hand side of the slide. So the same logos that we integrate in the Open Targets platform link to questions navigated to large language models via our MCP. I think that the key for us here is that we've studied the benchmarking. As I said before, when you ask things like large language models, these more detailed technical questions, you will always get an answer that's confidently stated. But in our benchmarking, we're able to improve the correctness of that answer from 50 to about 90%, and that's just in the first version of MCP. And I think that's important to bear in mind, is that the connection to the kind of ground truth will really help these more exploratory methods of querying and answering data and addressing big questions achieve higher accuracy. And we've seen strong demand for the MCP that we've built as it's been connected to different models. So just to finish this little tour of some of the work that we've done in Open Targets, all enabled by the fact that the data sources that we work with have licenses that enable us to work with them and bring them together. So I'd like to summarize by saying that big, complex problems are often going to require cross-domain expertise, and that often expertise and data can be siloed by discipline or data type, and we need ways to work across them to enable the bigger questions to be answered. So imagine you had to rebuild the foundational work that we've done every time you wanted to answer a drug discovery question, or that the integration we've done was not possible or gated by a complex landscape of agreements and fees. I want to acknowledge that being open is not free. There is a cost to provide the data to the community and opportunity costs to capturing value over time that I think are worthy of discussion and worthy of understanding, and maybe in some of the Q&A we'll get to that. But to finish, I think the impact of any one resource is going to be its standalone value times its potential to be integrated with other data sets to answer bigger questions. And much of the technology that we're developing is moving in that way, and it's important to understand how we can build a licensing landscape that allows the data that we work with to have its highest possible impact. So I'll stop there. I hope that's been interesting and useful, and we're happy to take questions as we move through the seminar.
Thank you, David. That was really useful to hear the impact of licenses on drug discovery. So now I'd like to hand over to Dr. Benjamin White from the Centre of Intellectual Property, Policy and Management, Bournemouth University, and Knowledge Rights 21, and he'll be sharing how licenses and copyright shaped who could access and act on critical research during the COVID-19 pandemic response. Ben, you're just muted.
Can you see my slide?
Yes, we
is
can.
What I was trying to say. Okay, thank you very much. Good morning, everyone. I will be. I suppose I'm presenting a slightly different picture here. We've heard just about Europe PubMed Central and how that relies on material openly licensed under Creative Commons licenses. And obviously, as Summer showed, those licenses vary from more restrictive to more flexible. And at the flexible end, you have Creative Commons attribution licenses. Although if you're based in Europe, I think in terms of machine learning, that obligation to acknowledge rights holders creates problems because of the scale of material that you're using. Although I'm not really here to sort of critique the Creative Commons licenses per se, but the reason that Europe PubMed Central uses Creative Commons licenses is to facilitate sharing of information and obviously allow commercial and non-commercial entities to do research, which the European copyright framework makes a distinction. So in Europe, the copyright framework only has flexibilities to allow non-commercial research, which creates problems for obviously commercial organizations, and I will be talking about commercial organizations in my presentation because I'll be talking about pharmaceutical companies. But it also creates problems for institutions that want to share data as well. So what the case study that I have is around the development of the corona vaccine, and I'll be kind of comparing and contrasting really what is possible legally in Europe as opposed to what is possible in the United States when you're using material that is subject to copyright, which is not under an open license. And of course, the majority of information is not under a Creative Commons license. So as you see with Europe PubMed Central, essentially what is happening is because of copyright, what is medical research is in the context of Europe PubMed Central is limiting itself to a comparatively small subset of information that otherwise could be used for machine learning of medical information in this case. So few copyright basics. Copyright protects original authorial expression, so books, articles, clinical trial reports. It doesn't protect facts, data, relationships, trends. So the copyright issue when it comes to machine learning is that very often the facts and data, trends, relationships that sit in articles, clinical trial reports, websites, etc., the facts themselves are not protected, but they sit in what I call a copyright wrapper. And that's why copyright law is as one professor in the United States, copyright law has the potential to bring artificial intelligence to its knees. And that's because we use computers to do data analysis and computers make copies. And that's why copyright law runs through the entirety of any discussion around data analytics, AI and machine learning. However, at the policy level, that is not understood, it is not surfaced. So if you're looking at the current debates, policy debates, they entirely focus on generative AI and generative AI that involves materials from the creative industries. So if you read on the BBC website, for example, about AI and copyright, you will only hear about the creative industries. And I suppose the one exception that I would highlight around this is news on Friday that people in the UK will have seen. The BBC said that OpenAI has stopped its investment in the UK, a key plank of Keir Starmer's AI policy. And it gave two reasons to that. And one of them is copyright law. So OpenAI has suspended its investment in the UK because copyright law doesn't facilitate machine learning. And I think, that isn't just a UK disease. We see this in Brussels as well, whereas the European Union, again, the debate is all about the creative industries. And here we have launched very recently the AI Continent Action Plan. Lots of good stuff going around AI, but it doesn't mention the elephant in the room, the laws that allow whether copying is permissible for machine learning or not. So I think at the policy level, there are clear weaknesses and a lack of understanding about the legal framework that sits and contextualizes machine learning. So moving on to the case study, we know that the pharmaceutical companies used machine learning, AI, to speed up the discovery process. So the academic literature was mined to establish the most promising protein spikes to prioritize for research. So by analyzing, and of course, the coronavirus is the most common virus on the planet, lots of literature. There's 5,000 medical publishers, it's estimated globally. One would assume that a significant percentage of those publishers would have published something about the coronavirus. So the pharmaceutical companies use machine learning to analyze that literature to speed up the discovery process, and therefore by doing that, saving millions of people's lives. It also analyzed the open web, social media, I presume, as part of its rollout. So it did that in order to analyze where there was skepticism, what the narratives were around skepticism, and also to prioritize where to roll out the vaccine. And if you were based in the United States, if you were a large pharmaceutical company like Pfizer and BioNTech, you would have had legal access to websites and the literature which you would have bought or licensed. In the United States, there is a flexibility, it's called an exception in copyright law, which would have supported Pfizer and BioNTech doing this. They wouldn't have had to have gone back to, 1,000 publishers, 1 million website owners, negotiated with X, Facebook, etc., to analyze social media. It could have just gone and done it. And that's because fair use, this test in US copyright law, essentially creates a test. And so essentially it says if the use of a copyright work is fair, depending on the purpose and character of the use, the nature of the work, the amount of the work, and the effect on the market. So purpose and character of use, what does that mean? Essentially, what the US courts have done is they have defined machine learning as transformative. So the purpose of writing books and academic literature is for human people to read. The purpose and character of AI is entirely different. It is to analyze and extract facts, data, and relationships. So essentially, it is a transformative use. It doesn't it doesn't impinge on why people write articles or books. And therefore, the courts routinely find that machine learning is fair under the first prong of the fair use test. The nature of the work, is it a more commercial, sort of creative work? Is it less so? Obviously, when we're talking about science, this kind of material isn't produced by commercial creators. So often the courts will find that the nature of the work also finds in favor of fair use for machine learning. The amount of the work, is it proportional to the use? Obviously, in order to do data analysis, you have to copy the whole thing. So courts will often find that you can use the whole work. And then again, we've sort of touched on the effect on the market. So the analysis of scientific material to develop the coronavirus would not have impinged upon the purpose of the authors or indeed the publishers, because they were extracting facts and data in order to develop a virus. A virus vaccine does not compete with the original publications. So we can see that in the United States, if you're a pharmaceutical based there, you could have accessed essentially anything you had legal access to for machine learning purposes. This contrasts heavily with Europe. UK copyright law doesn't allow commercial AI at all, even if you already have access to the content. And similarly, it doesn't allow the sharing of data across legal entities. So I don't know what AstraZeneca did and what Oxford did, but let's do a thought experiment. If they use machine learning, then under UK copyright law, under UK copyright law, Oxford University could have done machine learning on the literature on websites without seeking permission. But because it was working with a commercial entity, AstraZeneca, if they use machine learning, then they would have had to license access to, potentially thousands and thousands of websites and articles. Simply not possible at any scale and any speed. EU has slightly different copyright laws in this respect, but still it doesn't allow sharing of data across legal entities. It create and or across borders. It does allow some commercial use, but it allows commercial rights holders like scientific publishers to say, no, you can't use the material that you have lawfully accessed, lawfully acquired. You have to come back and renegotiate for AI purposes. And as I said, anyone with any licensing experience will tell you that is just simply not possible at any speed or indeed any scale. And as the Indian government in a recent report on generative AI has underlined very clearly, a system that relies on voluntary licensing, you have to relicense the material for machine learning purposes, is going to reduce the volume of content and the right kind of content, the veracity of material that you can use for training your models or analyzing data. And clearly, a model created in a system which has less content and less of the right kind of content, as we see in the UK and Europe, because you have to license materials, is not going to be as good, as accurate as a model created under a system like we see in the United States or Japan or Singapore or South Korea, other countries with more flexible systems. Because once they have access to the material, there is no limit. They don't have to relicense again in order to get their machines to do machine learning on the content. So essentially, a system that depends on voluntary licensing, as we see in Europe, is going to reduce the content and therefore ensure that the models are just simply not as good as models developed in other parts of the world that have more flexible copyright systems. So essentially in Europe, if you're a researcher, we work in a highly complex system, with high overheads in terms of AI, requiring licensing, which is as any licensing professional will tell you, simply not scalable and not workable. And I've probably taken over my time already, so I'm now done. Thank you very much indeed for listening.
Thank you very much, Benjamin. That was really helpful to see the impact of copyright and licenses on COVID-19. So I'd like to thank both David and Benjamin for the compelling case studies. They'll both now be joined by 3 additional experts for a panel discussion. This will include Dr. Bastian Drees, the Head of Office for Scientific Information Management at EMBL, Dr. Kiera McNeice, who is the Research Transparency Manager at Cambridge University Press. I must state that all views that Kiera will share are her own and do not represent Cambridge University Press views or policies. They are hers alone. And Melissa Harrison, the Literature Services Team Leader and Europe PMC Lead. So for this part of the session, what we'll have is I have some questions for our panelists that they will then discuss here for us. So the first question I'd like to ask you all is, what community problems are currently blocked due to an inability to bring data and resources together? Is there someone that would like to take that first?
I can jump in, I suppose. So I previously been on the Horizon Europe Future Text and Data Mining project, and we talked to a lot of researchers around Europe about different kinds of machine analysis they wanted to do for various purposes. And as Ben was saying, a lot of the time you end up seeing cases where, because the research institution, even though they're totally non-commercial, might be partly funded by a commercial entity or a pharmaceutical company or something else, then that can be a commercial connection. And then that leads to it being potentially a copyright risk for them to go and try and use machine analysis of, say, all of the journal articles they've paid for access to through their university library. And so what we saw in a lot of cases were that, researchers just did not have the capacity to do rights clearance at that sort of scale. And so, and the universities, especially publicly funded universities, were worried about the risk of infringing on copyright, and especially when it belongs to the major publishers around the world. And so this was having a chilling effect on research in many different sectors, especially where researchers wanted to analyze existing published literature. Of course, it's more and more we're publishing open access content, and that makes it more accessible for people to reuse and analyze with machines. But there's still huge amounts of publications and research outputs that are not under open licenses. And again, as Ben was saying, that means that you're limited to what kinds of content you can analyze if you want to use machine analysis, and which means that you might get biased results or limited results.
So if I could just follow on from that, using the example of open targets that David was describing. So Europe PMC does a lot of text and data mining of information that then goes across to open targets and mixes in with other information from other databases to kind of provide the evidence. And I'm going to circle back into the CC licenses. If the content is published under CC by non-commercial license, it means that we can't provide that evidence into open targets because it has because of the pharmaceutical companies funding it. But the issue is that open targets is an open platform for anyone to use, and it's a kind of pre-competitive space, and so it's limiting the use of information by adding more restrictions onto the licenses. So that kind of creates a problem.
Shall I just jump in, or shall I put my hand up and be all shall I be well behaved and put my hand up?
Yeah. Shall we go Ben, then Bastian, then David? Because I think
sorry, was
jump in.
I suppose taking a step back, it's always interesting to see in these webinars where we have people from, I think we have a lot of people from Europe. I can also see that we have people from East Africa and West Africa. And actually, Nigeria does have fair use. So in Nigeria, it has the same provision in their copyright law that I talked about. And I think it's important to state that in Europe, since 2001, the first copyright directive, the European copyright law, EU copyright law now creates a distinction between commercial research and non-commercial research. So, for example, in the UK, before 2001, there were exceptions for research. So if your purpose was for research, if you had access to the material already, you don't have to go and ask permission for certain sorts of uses. And now in UK law, data mining is one of those uses. So if it's for non-commercial purpose, data mining is allowed as long as you do it in your own institution. But in the UK, you can't share the training data or the results with another institution legally. So that creates, let's think about the NHS. So the NHS is actually divided into trusts. So an NHS trust, if it was doing machine learning, if it wanted to share training data with another NHS trust, although, the majority of science is publicly funded, of course, it then has to go back and get a license and negotiate licenses. And as I said in my presentation, and I was head of journal licensing at the British Library for 15 years, it's not scalable. And we see that coming out in some of the USAI cases as well, simply not scalable. But Europe is an outlier. Switzerland, for example, Switzerland doesn't make this distinction in its copyright law between commercial and non-commercial research. It just says if it's for research, and it's for machine learning, you can do it. So in Europe, we're an outlier, and that doesn't facilitate scientific discovery. It doesn't facilitate knowledge transfer where industry players are working with universities and publicly funded research organizations.
Thank you for sharing, Ben. Bastian, did you have something you wanted to add?
Yeah, thanks. So I wanted to, I'm not so much involved in any AI research projects. But in our day-to-day work, we frequently deal with copyright issues of the individual researchers that contact us. And I think apart from what Melissa and Kiera and Ben mentioned about the commercial, non-commercial aspect of the licenses, another aspect that we see often causes problems is also the ND part, so the non-derivative part of the licenses. So just let me give an example from our day-to-day work. So that like last week, we received a request from a researcher who wanted to reuse some figures from an article for a review article. And there were around 6 or 7 figures. Half of them were under a CC BY license, so no problem there. But all the others were under an NC or ND or under copyright. So we had to check basically every of these figures one by one, what was possible and to what extent. And that even went to that degree, like, is it even allowed to change the font size in those of the text in those figures, or is this a derivative? And I think for the question we are dealing with here, it's if even such a relatively straightforward project, it causes a lot of additional work. It causes, and I think the most important is it's not so much the question whether it's allowed or not. In this case, it was more about the legal uncertainty and that we were not clear, is this allowed or not? And for bigger projects where you need large amount of data, in the end, it basically, if you have a restrictive license, if in doubt, you just leave the data out. And this even goes as far as that even if you have an open license, but that license is not machine readable, then you would even leave those data out. And I think that is a problem that the creator of the data not always is aware of, because you think, okay, I want non-commercial, non-derivative. That is a good idea, but you're not really thinking about the implications for reuse of your data. I think that's what we see in our daily work a lot.
Thank you, Bastian, for bringing the ND license types into this conversation as well. David, was there something you wanted to add to this?
I was just thinking about fields which are blocks, but maybe I'll say slightly differently that in most fields, there's a very different mix of data that is available to use openly and data that is not. And that fields could be more fully enabled if over time some of the data that sometimes gets locked away in big projects that are not initially open for valid reasons because they've been funded by companies or there's some collaborational reason to initially not make it publicly open. A way in which data could be managed so that more gets opened up over time if it can't be open initially would be an interesting way to more fully enable fields. But I do think the kind of management of licensing over time is not something I see too often, and people tend to set the first license as their default position and then not evolve it as time progresses.
Thank you, David. And thank you all there for highlighting the challenges of NC and ND license types, the legal uncertainty around this, and how licenses are managed over time, and how data licenses affect the community and impact our community as well. So for our next question, I'd like to ask our panelists, what do people worry about when choosing licenses?
I can start if that's okay. So I think one of the challenges we're seeing with the literature especially is this concern about AI. And we're seeing that things are changing. So traditional citation metrics, traditional impact is so in the past it used to be usage. You could see it. You could see how many times your article was accessed. You'd be cited. All these sorts of things. And AI is just really blowing that all out of the water. And so we've got to think about different ways to kind of measure how the impact of someone's research. And I think that people are really concerned that they're not getting attribution from it. So if we think about the literature as big data and AI is coming along and kind of swooping through it and picking out like key bits, then I think a lot of scientists might be concerned, well, yeah, where's my stake in this? How do I kind of get the value? And how do I get the feedback on that? And so I think that could be why some researchers are aiming to go for more restrictive licenses. So we've seen at Europe PMC a quite large increase in NC/ND licensing rather than straightforward CC BY, which is what most funders are asking for. And I appreciate those concerns. I really do, because we're in a really changing world. But the concern that I have on the other side of it is, how AI is kind of going to be changing kind of what's possible and how using all of this data and availability to kind of discover new things and to identify things that people just can't do on the individual one-by-one reading articles. And just like with the examples of open targets and also developing the corona vaccine, and there are things that we're seeing that the other databases at EMBL are doing, like creating summaries of a kind of protein, for example, and being able to understand that and creating a kind of that is generative AI. But by putting a more restrictive license on your content, you're not making it available for these kind of big discoveries. And I think the other thing I just wanted to highlight here is that if you put a restrictive license on your piece of content, your publisher could still sell the rights to an AI company. So it's kind of limiting the open community, but it could still be made available to generative, to AI anyway, but you're not in control of it. So it's just kind of just a slight shift there. But it's just kind of limiting on one side. But yeah, Kiera, as a publisher, you might have something to say on
again,
this.
not representing a publisher today, just here based on personal experiences. But I wanted to come in on that point about it disproportionately affecting, the individual researchers, because there's a question in the Q&A about, well, why shouldn't pharmaceutical companies who profit from vaccines pay for the knowledge? They can pay for a bulk license the same way a university does. And I mean, yes, they can. A pharmaceutical company can do that. They can employ people to do the rights clearance. A university has, librarians who pay for bulk licenses and negotiate with publishers. But if you're a individual researcher, if you're a small startup company trying to develop something new, if you're you can't afford to take the risk of breaching copyright if you're analyzing a whole lot of content, and you can't afford to hire someone to do the rights clearance necessarily. So if we're limiting in the ways that the copyright law limits people's ability to use machine analysis for research or for any purpose, is actually to an extent consolidating power in the existing big companies and the entities that can afford to do rights clearance and can afford to pay for licenses and can afford to negotiate and can afford to take the risks of being sued for copyright infringement. So in fact, yeah, the overall effect is that it impacts individuals and impacts, publicly funded institutions who can't afford to take risks far more than it does the big companies that can negotiate licenses.
Thank you, Kiera. Benjamin?
Yes, a couple of points, not necessarily in a logical order, I have to add. I think it's very important that we understand, a lot of the press focus is obviously on large US multinationals. Obviously we know about sort of Chinese and Russian bots scraping lots of stuff, but as Melissa said, that's only one part of machine learning. There are lots, as we see with PubMed Central in the scientific sector. All sorts of organizations need access to scientific information. So, it's really important that people understand that, which is why open licenses are so important. Open brackets, subject to my caveats about the obligation for acknowledgement in Europe doesn't create a problem in the United States. But it's really important that people realize that machine learning is used by all sorts of organizations. And of course, vast majority of scientific material is publicly funded. So we're going back to the good open access arguments that this is publicly funded. The funders fund science in order for people to share it, so we can, innovate faster, create medicines and treatments faster. There's a real kind of public interest element here. And voluntary licensing, as I said in my presentation, in Europe will just drive less good machine learning, which I just don't think is in anybody's interests. Of course, we see the larger players, are putting links to materials. So in that sense, attribution is happening with the larger LLMs. And just to reiterate what Melissa said, we see some of the larger journal publishers encouraging authors to put material, although their funder might require it's under a CC BY, to put it under a more restrictive non-commercial license. And what appears to be happening is the publisher then takes the commercial rights, and then, as Melissa said, and I've put in the chat, there's a tracker of of agreements between big tech and the scientific publishers. So essentially, the stuff is ending up there anyway, but publicly funded science is yet again being privatized in the realms of machine learning, which we now have 20 years of the open access movement, where we're trying to get more scientific information, more research information into the public domain. And yes, that will benefit big tech, but our hope on this panel is it will facilitate scientists and researchers and research organizations, pharmaceutical companies, etc., etc. That's kind of what we want, and for that we need kind of an open licensing environment and a more flexible copyright environment.
Thank you, Ben. David?
Yeah, just probably a pragmatic point in that this is it's a fairly complex space. It has its own terminology and language, and some of the researchers making this decision may not have grappled with it in depth on all occasions, and so they choose something they're either familiar with, or something that's recommended to them, or something where they are limiting the unknown factors that they haven't quite grappled with in the past. So increased education and training for folks around what different licenses mean and represent, what opportunities they can provide in the future might help people make the decisions that they want to make with the best set of information behind it.
Thank you, David. Melissa?
Yeah, I just wanted to add another point of training models and training data sets. So, for instance, if somebody has navigated all the access rights and has trained an LLM on a set of data, if that data is not open, then that data set can't be made open. So again, I'm just thinking of, open access for the literature, but open data, but also so the machine learning world and all the research that's being done there and the publications of that, we've spent a lot of time pushing, trying to promote open access, because that helps, because publicly funded data, but also researchers can access it, and the same with the data. But we're on a new level of data sets here, and if the data sets that train a model, if that's not open, then people can't analyze what the algorithms are, how they've worked, and can't kind of be feeding into that as well. So again, and also if you think about it from an attribution point of view, if your data that if for instance it's a literature article and it's been made open access and has an open license, it can be part of that open data set, and so that it's been used for this. But if it's closed, then again it doesn't become obvious to everyone that it's been used. And it kind of, as Ben was talking a lot about the quality of the models, if the data that was used to train the model is closed and people can't analyze it and know and look for biases, then we're kind of compounding the problem again.
So thank you all for highlighting the literature concerns that we're seeing and this increase in NC and ND licenses, and how AI and big companies are less affected than the individuals in our community due to general power dynamics, and talking on this point of needing increased training on licenses to help people make decisions. My next question for the panel will be, if researchers are increasingly concerned that their openly licensed work might be used to train AI systems without their consent, how can we balance the need for openness with the desire for control?
I think there's frankly an education and discussion piece, which hopefully this webinar is contributing to, and understanding that, if you make something CC BY, it's not just out there for AI to use. Anyone can use it for any purpose you disagree with. And that's something that you have to make peace with if you make your research outputs CC BY, and decide whether or not that's worth the benefits to the rest of the research community of everyone being able to reuse and build on your research without worrying about getting sued for copyright infringement by you or by a publisher. So there is a trade-off there, because the more open you make something under its licenses, the more people can use it for, and the more likely someone is to use it for something that you disapprove of. So I think fundamentally that's something that researchers should be more aware of. I know we had a session with the Cambridge University Data Champions a few months back where we discussed exactly this. Yeah, so I think enabling researchers to make informed decisions about licensing and how open they want to make something and why, and what the potential benefits and impacts of that are, is the most important thing here. Because there are cases where someone has a genuinely good reason for not wanting something to be, say, under a commercial license. I remember we've talked to people who do research on Indigenous communities who often who are very strongly opposed to people commercializing their culture and their knowledge. So they're happy to share things for research only under the condition that any outputs will be under a non-commercial license, which I think is extremely fair. So yeah, giving researchers the information and tools to make informed decisions, I think, is the most important thing here.
Thank you, Kiera. Bastian?
Yeah, thanks. I think Kiera's point is very reasonable, and I think from my experience, what most people worry about when choosing license is the feeling of losing control over their content, and especially if it's about new forms or unknown forms of reuse, like now with AI. And in many cases, this is a very emotional concern, I would say. So when I worked at conference recordings, for example, people had no problem at all, or many people had no problem at all to share their video recordings with and upload them on YouTube, basically signing away all their rights. While if you ask them to publish the same content under a CC BY license on a library repository, they were concerned about what this might be used for and whatever. And I totally understand the concerns, because I don't know, I heard this more than once, that people were afraid that someone would take it and put it on TikTok with bunny ears on their heads or something like that. And it's totally understandable, but the question is if copyright and licensing is the right tool to solve such a problem. And on the other hand, there's an increasing amount of AI tools. So we are always thinking, when we're talking about AI, we're thinking about generative AI, we're thinking about ChatGPT or something like that. But there's also an increasing amount of AI tools that are built by scientists and for scientists. And so there was this EMBL symposium last month about AI in biology. And so if you look, for example, at the most prominent tool, AlphaFold, then what you see is that such a tool is only possible to build, or was only possible to build, because it builds on decades of open and well-curated and well-structured data that was available to train those models. And as Kiera said, it's something you have to balance. It's the question. You have to be aware that if you use restrictive licenses, you limit these kind of reuse. And the question is, do those restrictive licenses really give you control over your content, or is it just a feeling of more control? And so I think that is the challenging conflict that we're in this question.
Thank you, Bastian. We'll move on to Benjamin's comment before moving to the open Q&A.
Thank you. So I think you sort of posed the question that the decision point was publication. And I suppose I'd like to highlight that, many funders, as a condition of funding your research, require that your research outputs are put under a Creative Commons attribution license. So, for example, UKRI, but all across the world, many funders require the use of CC BY licenses. So actually, the decision point for you isn't the publication. It's actually whether I should apply and accept this grant for my research, because it requires that the material is available under Creative Commons attribution license. So as a researcher who hasn't signed up to an obligation to put it under a Creative Commons attribution license, and therefore it can be used for any purposes. I guess I would just reiterate that, by the decision is, do you want it on the web? Because once it's on the web, and of course, internet search is a form of machine learning as well. It is going to be used for different purposes, and as I've highlighted in many jurisdictions, the law allows you to analyze the data. So even if you put it under a restrictive license, if you're in Japan or Singapore or America or Nigeria, etc., you can use it anyway. So you're not preventing use, and I think in more restrictive jurisdictions like Europe, where you would be preventing use, I would encourage people to think about the public interest purposes. Do you really not want the NHS with a pharmaceutical company working in collaboration to use this material? And again, finally, I think a lot of the narrative around this is about big tech. But as the Indian government quite rightly pointed out, that big tech has deep pockets, and they will, as we see with the licenses with publishers, go and buy access anyway. So what you're stopping is smaller players, startups, SMEs, public institutions with less money from being able to use this material from machine learning. So it stops competition, it stops good things happening, because the people with the deepest pockets will get access any which way.
Thank you to all of our panelists there. So what we're hearing is that the CC BY, anyone can use this for a purpose, and that means that you may disagree with that, but is that worth the benefits to the research community? And we hear that there's this fear of losing control over the content, particularly with the reuse of AI. And are restrictive licenses giving control or just giving that feeling? We know that different countries have different laws that affect reuse. It's not just the license. Grants are dictating which licenses you need to submit as well. And in general, as we've discussed, these bigger players with more money and more power are still able to get hold of that content. So in general, it seems that you're more so restricting individuals and smaller players. So I think one thing that's been clear from this webinar is we're aiming to help researchers make informed decisions with these discussions and understand the impacts. So on that note, I'd like to open the floor to all of you, the community, for our Q&A session. So you are welcome to raise your hand and turn on your camera if you wish. I will call on you if that's the case. And do remember, though, this is being recorded and will be shared. You're also welcome to use the Q&A where you can submit with your name or anonymously. So our first question from the Q&A is for Benjamin. So this is from Kristin Radford. So why shouldn't pharmaceutical companies who profit from vaccine development pay for the knowledge they are mining, much as which has been created by the non-commercial sector? They can purchase a block license in the same way educational insets do. Oh, you're just on mute, Ben.
Yeah, and that's what they do. That's what they do.
And then
Yeah, so I think I sort of brought this up earlier, actually, because I read this in the Q&A, and yeah, I think, again, they can, but then copyright law is such a blunt instrument that if everyone needs to pay for a license to be able to do machine analysis of research outputs or any other content, then yeah, the big players with the deep pockets will pay for it, and everyone else will face a much greater challenge.
I mean, to me, this is the sort of archetypal open access. It's not double dipping, it's not triple dipping. This is now quadruple dipping. So majority of science is publicly funded, as we know. Then our institutions have to buy back those results. Then they have to buy a collective license in order to share those results, put it on an intranet in their organization. And now they have, in the UK and in Europe, they have to go back a fourth time to analyze facts and data which are in the public domain anyway, and the copyright wrapper has been publicly funded once, twice, three times, and now a fourth time. That doesn't sound like a good deal for society, as far as I'm concerned.
And then to follow up there, is there a role for the UK or EU licensing body to carry out machine learning for commercial research, corporations to pay a fee based on their turnover? And is this held in trust for research organizations to bid for support of new research? So is there a licensing body to issue licenses for machine learning?
No. No, because the collective license, well, okay, so of putting aside the quadruple dipping issue, essentially the way that collecting societies operate is they operate on an opt-in. So they can only license works that they're given permission to license. And, you know, the larger players don't want third parties to license on their behalf. They disintermediate collecting societies. They want people to go directly to them. So collective licensing is not, again, not scalable. It only offers a subset of access. So it's going to drive bias. Again, this is a European kind of way of approaching it. It just makes the UK uncompetitive and makes other places more attractive to do research. So this is why the Indian government, because of problems with voluntary licensing, with collective licensing, the Indian government has put forward a proposal that they will have a mandatory license. So no opt-outs is my understanding. If you want to use stuff that you have access to, whether that's the website, whether that's licenses of journals, whatever, you have to pay a mandatory license to the government, who will then distribute money accordingly. So again, kind of gets to the same place as fair use, but more bureaucracy. So we don't know if that proposal will come into being. But again, so they've rejected collective licensing and voluntary licensing as unworkable.
Thank you, Benjamin. So our next question is from Jessica Hudry. So it looks like all panelists feel that licenses should be more open to facilitate AI for research purposes. But are there any reasons to maintain restrictions to prevent inappropriate use of data by AI companies, or do the licenses simply not sufficiently address that inappropriate use anyways?
I think I'd agree with that second point, that the licensing of the research that's all pulled together to perform AI isn't the way that you could control inappropriate use. But that's an opinion.
Yeah,
No,
I think there's limitations to what, sorry, do you want to go first?
No, go.
Yeah, there's limitations to what can be done with copyright, again, because it's such a blunt instrument. And within research communities, there are already a lot of norms that are not legally enforced, but like ethically enforced in terms of, you know, citation and attribution and how people behave when sharing and reusing research. So I think there are certainly community norms that can help to establish, you know, the best ways to deal with research and reuse research without restricting things legally in a way that would stop genuine public good benefits and public good uses.
Thank you, Kiera. David?
Yeah, I think I disagree that the technology itself is amoral, if you see what I mean, in terms of how it can be used, and the licenses are part of a toolbox of laws and ethics that go along with it. They're not the one solution for everything. So I don't think the license is the right place to address improper use.
Thank you. So our next question is from Isis Trajango. How do you think CC signals can contribute to protecting the rights associated with research data and outputs?
I think this is an interesting initiative from Creative Commons, which I instinctively kind of like. Again, just going back to my concerns about the inability to attribute at any scale. So Creative Commons try and deal with this, and they give sort of examples of, well, you don't have to. The example that they give, unless they've updated the website that I saw a couple of months ago, was, well, you don't have to mention each rights holder. You just mention the data set that, or the database that you've used. I, I, I just that to me is not attribution in a copyright sense. I I do think, like we see, if we're thinking about the large commercial multinational LLMs, we do see them increasingly linking data to the sources that they've used. It feels to me that, and in the UK, for example, UK copyright law only requires attribution if it's practicable. And I kind of think it's that kind of language, if it's practicable. I think dealing with attribution is clearly complex. It's important for lots of different reasons. And I just don't feel. I think it's going to kind of develop over time, and it's going to be about norms and behavioral norms rather than the black and white letter of the law.
Thank you, Benjamin. If there's no further comments from the panel, I'll move on to our next question. So this is from Giada Gelli. Very interesting session highlighting licensing obstacles. On a similar note, I wonder if the CC by SA would be a good solution to allow mining for commercial purposes with the provision of sharing afterwards. However, would the commercial entities be content to share the outcomes and data of their research afterwards?
I can take a quick step of this. So I guess, so in Open Targets, we work with the pharmaceutical industry. We devise projects and programs together, and within those projects and programs, we share the research data and findings from the projects with them, and then ultimately publish everything. But what we hear back from the companies is where the work that we've done has been impactful, but not specifically what they've done with the work that we've done, because it becomes a kind of trade secret within their company before they can ultimately then put some patent protections around it, and then pieces get disclosed later as projects develop into full commercial products that have the kind of patent and intellectual property boundaries around them that are needed. So I think I would say, and if my first reaction is that most companies will need some element of the trade secrecy to provide the commercial benefit to them from the work that they're doing. Then, so initially, I think that will be a big ask. However, you can see versions of the world in which, if we're working on a shared problem in a pre-competitive space, or maybe after some period of time, there could be some release of research into the public domain. And many kind of scientific life sciences companies do publish, because that is actually an important part of their scientific credentials. But I think it's a question of timing versus when they're trying to do the work for pure commercial factors, and then later bringing it out to the community once they've secured the rights that will enable them to get their commercial benefit.
Thank you, David, for sharing that insight. Did any of the other panelists have anything to add before I move on? No? Go on.
I think it's a very interesting question, but again, just taking one step back, I think where Giada's going with this is sort of, trying to create benefit downstream from large actors accessing content. And I think, I mean, if you think about the excessive market concentration of AI markets, and then if you think about bodies of law in Europe, which are informed by competition law, like Digital Services Act, Digital Markets Act, Digital Data Act, we can sort of see the European authorities thinking about these market incumbents and how can we encourage more competition. At the moment, all they're doing is just regulating, a market that's tipped. So you have these market incumbents, gatekeepers, the market's tipped, and they're sort of tinkering around the edges. I think what we need to think about, and I think this is where Judd is going with this question, is actually, if we have these very large, powerful players, how is it that smaller actors in these markets can benefit from gatekeepers? I'm not sure CC by SA is necessarily the answer here, but I think kind of access rights are an interesting way that we can start to think about this. If you're defined as a gatekeeper in an AI market, then you have to license out perhaps data sets or your model weights under kind of fair terms and conditions. Yeah, that's how I'm sort of interpreting that question. That how can we create more competitive markets and encourage new.
Thank you, Benjamin. So I'm just going to say we've got 8 minutes left, and there's 3 questions that I'd like us to get through before we wrap up. So the next question is the issue that copyright law or licenses are perceived to be controlling what would be unethical behaviors? It seems to be the wrong tool, but it might be the only tool that researchers are aware of, and the recourse mechanism for misuse are perceived to be less effective.
Yeah, I think absolutely putting all the emphasis on copyright law to, protect content, it's not covering all the potential unethical behaviors. It's not necessarily solving the problem. And Melissa, did you have something to add? I see you nodding there for the question. Yeah, I think it's probably true that it's the only tool that researchers are aware of in a lot of cases. And even then, they probably don't have a lot of understanding about, again, the impacts of different CC licenses, about putting that non-commercial clause on. But yeah, again, much of the conversation here is all about, the only unethical behavior we're talking about is who's getting paid, right, with the copyright law, who's getting license fees and things like that. Whereas there are a lot of other unethical behaviors that could happen that are not controlled by CC licenses or by copyright generally. So yeah, when it comes to science and machine analysis and all these sorts of reuse, just relying entirely on using copyright to try and restrict things, I think is not effective and has all the drawbacks that we've been talking about for this panel.
Thank you, Kiera. I see lots of nodding that was going on there from some of our other panelists. I'd like to move us on to the next question. What is the best way to deal with ResearchGate requests to share publications?
I think that's a bit out of scope, isn't it? I don't know, maybe others I don't understand the question. It feels to be out of scope to me.
Yeah, I'm not sure that's something we can really answer here.
Okay, thank you. We'll move on to our next question. So from Margaret Owen, how do current licensing models affect researchers and institutions on low and middle income countries? Do restrictions protect them or exclude them? And could more open licensing unintentionally enable extraction of data from the global south without fair benefit sharing?
think for the second part of that question, I mean, absolutely it could. That's a risk. And which is again where, benefit sharing and ethical practices are something that we can't control necessarily with just copyright law and licenses. So in terms of protecting the global south and avoiding things like data extraction and exploitation, I think, that has to be a cultural and an ethical approach rather than necessarily something that can be strictly controlled by licenses.
Thank you, Kiera. Melissa?
Yeah, no, I agree. It's a really complex and concerning and difficult area. But the one thing that I often think about though is if if there is like clinical data from a country in the global south and that information is not within the data sets that are developing new drugs, then that could have an impact back on people in this area because it's not going to be good for them. So I totally appreciate the concern there, but what I often worry about is the bias in the literature, the bias in the models that are being developed that are going to alienate certain parts of the population because their data set isn't involved.
Just to absolutely agree with Melissa, if you Google machine learning, AI, medical bias, you'll find quite a lot of literature regarding that treatments have been developed, and yet because of a lack of data from South Asia, for example, they're not optimal for those populations. So yes, there's yeah. Again, as Melissa said, it's sort of the downside is it creates bias.
Thank you. And we've got one final question. Do we need public AI to better facilitate open data and open access?
To me, this is kind of, again, a bigger question. It's about the growing importance of sort of digital sovereignty. Yes, I do think it's important that regions around the globe are more independent of these large US multinationals, and that requires lots of things. That requires education, it requires public investment in digital infrastructures, it requires training, and it requires better laws that govern the use of information. So that, again, we're back to copyright and licensing is part and parcel of that digital sovereignty debate.
Thank you, Benjamin. Any final comments on that one from any of our other panelists? David?
This might not be exactly where it was going, but we haven't talked about this much today, but as well as there being a kind of commercially driven development of AI technology, there is an open source movement that's kind of tracking it side by side. And the licenses that we're working with facilitate that so that kind of technology can be competitive with some of the commercial models and more freely available to a broader set of the community. So that is just something that is kind of tangentially connected to the question being.
Thank you, David. And that is the end of our Q&A session, and we are coming to end of time of this webinar. So I'd like to say a huge thank you to all of our speakers and panelists, Melissa Harrison, Dr. Kiera McNeice, Dr. Bastian Drees, Dr. David Hulcoop, and Dr. Benjamin White. And of course, a massive thank you to everyone who has attended this webinar and engaged in the chat